Hello, I welcome you to this session. Thank you for joining us. A session that is aimed at simplifying and seeing how possible we can apply the R formula in solving trigonometric problems. With this, purposely we're going to have a peer review of what we did with the compound angles, because when you look at the compound angles peer review, that's the best way you can bring out the R formula to every person to understand it. Thank you. Now, when you remember very well, under compound angles, we say if we have maybe two angles, A and B, and we are adding, or either adding them or subtracting them, in expansion per sign, we shall have sine of A cos of B. If we are taking the positive sign for a sine ratio, we maintain the sign in between these angles. If it is a subtraction, also maintain it. In that sense, we shall have cos of A sine of B. If you remember very well for a cos of A plus or minus B, this one, cos of A, cos of B. However, if this one is positive, the sign turns into a negative, just like it was proven when doing compound angles. When we subtracting, the sign becomes a positive. Sine of A, sine of B. Now, having this in place, this one gives you a stand on expressing any expression in this form. Say, if someone told you, express A cos of theta plus B sine theta in the form R, this being a cos, written first, this person must look at the cosine ratio. And this being a positive, we say wherever you have a positive in the result of the expansion of a cos, it means the initial expression was a negative. Just like you see here, if it's a negative, turns into a positive. Having a positive here is an indication that the initial expression had a negative sign in between. Cos of theta minus alpha. If someone is told to express this one in that form, let's see how this can be done. In your solution, the purpose of this is purposely getting the value of R and getting the value of alpha, because in the initial questions we don't have R, neither do we have alpha. So you need R in terms of A and B, and you need alpha either in terms of theta or in terms of A and B as well, just like the original question states it. If we say, when you look at this, it is practically identical to this. It is practically identical to this. So from R cos of theta minus alpha, if you try to expand this, we shall have R, put a big bracket. We have cos of theta, cos of alpha. We are now using a cosine expansion. In expanding this for angles A and B, instead now we are having theta and alpha. We are taking the negative sign, not the positive. So, plus, since this is negative, it turns into a positive. Plus sine theta, sine alpha. When you have this, multiply alpha, we shall have R cos theta, cos alpha, plus R sine theta, sine alpha. Now, when you look at this, rearranging this is such that cos of theta comes after cos of alpha for purposes of comparison here. So you will have r cos alpha cos of theta plus r sine of alpha sine of theta. When you look at it clearly well, this one and this one, this is a coefficient of cos theta, and this is a coefficient of sine theta. Now put your eyes back to the original question. The coefficient of cos theta here is A, and the coefficient of sine theta is B. So what you do, you're going to compare the coefficients of the result of the expansion and the coefficients of the original equation. So next we comparing coefficients. We shall have A giving us r cos alpha. That's practically A, because A is a coefficient of cos theta. So we are now equating and comparing the coefficients. And B shall be the same as, now B being the coefficient of sine theta, it is practically equivalent to r sine of alpha. R sine alpha. Now, having this in place, if you divide here by r and divide this by r as well, so we shall have cos alpha giving us the out of r. And if this is equation 1 maybe, then we have sine alpha giving us b out of r, and call that one equation 2. From sine squared theta plus cos squared theta equals 1. Hope this one is variable and it stands. That wherever you have a cos squared of an angle plus sine squared of an angle, so long as the angle is the same, and these are two squares, we always get 1. So we shall have b squared out of r squared plus a squared out of r squared giving us what? Giving us 1. When you get the LCM, we shall have a squared plus b squared giving us r squared. So when you get the value of r, practically will be the square root of a squared plus b squared. When you look at our question, our a sometimes may be given, our b may sometimes be given. You just make a substitution to get the value of r. After getting our r, now the task is, how do we get this alpha? How do we get that alpha? To get alpha, we can use two ways. One, we have a sine and a cos. We can possibly get a tan. Or we can use a triangle. There are two ways of getting the value of alpha. When you get equation 2, divide by equation 1, we shall have sine alpha divided by cos of alpha, and this will be b over a. So we shall have b out of r divided by a out of r, giving us sine alpha out of cos alpha. When you get the reciprocal here, r will go up, a comes down, so r will cancel out. So you will have tan alpha giving us b over a. So to get the value of alpha, we shall always say the arctan of b out of a. So when you come back and look at the form they wanted us to find, had we gotten the value of r, assuming a and b were given values, had we gotten the value of b and a, so we will easily substitute and say, therefore, a cos of theta plus b sine theta should be the same as r, which is the square root of a squared plus b squared cos of theta minus the arctan of b over a. That will be the form. In that sense, then you have to, if you can look at a practical example, so if you can look at an example, if someone told you express, yes,
3 cos theta
3 cos of theta
plus 4 sine of
plus
theta
4 sine of theta
in form r cos
in the form, yes,
r cos theta minus alpha.
r cos of theta minus alpha.
Hence,
solve
3 cos of theta
3 cos theta
plus 4 sine of
plus
theta
4 sine theta
is equal to 2.
equals 2. Do we have the range of angles? The range of values is which angles?
For 0 is less or equal to theta
less or theta
less or equal to 360 degrees.
360 degrees. Now look at such a question. If such a question comes, practically someone who understands this, find this very, very appeasing and very simple. Because now our A is 3, our B is 4 in this sense. And remember, we are starting with a cos, a sine. Cos, sine. This is not different from what we had. We started from a cos and sine. In this sense, if we are expressing 3 cos theta plus 4 sine theta in this form, just start from here. So, from now, before I even continue, it is very okay. It is very fine and very okay. Wherever you have this, to just say for r equals, it is very okay and very fine for just r equals the square root of a squared plus b squared. This is from r equals that. So we shall have r giving us the square root of 3 squared plus 4 squared, which gives us, this is 9 and 16, that's 25. The square root of 25 giving us 5. And that is your r. After getting r, it is also very fine to find alpha. And alpha shall be the same as the arctan of b over a. But our b is 4 and our a is 3. So we shall have alpha giving us the arctan of 4 over 3. And what is the answer? Getting the answer for this. When we get the arctan of 4 over 3, arctan, what have you gotten as your answer? 53.1 degrees. This is 1 decimal place. After having these two, it is very fine. I'm rubbing off this. It is very fine after having your alpha and after having your r to come back and say, because you're putting it in that form, I'm going to say, therefore, 3 cos theta plus 4 sine theta is equivalent to r, which r is 5 cos of theta minus 53.1. You've expressed this in that form. Our purpose is getting the value of r and getting the value of alpha. After having that, you've expressed in the form. Now, they say hence. In mathematics, hence means from where you have stopped. Now that you've stopped here, and they are saying hence solve 3 cos theta plus 4 sine theta equals 2. This is exactly this. An implication that this one is exactly what they want. So it is now hence 2 is equivalent to 5 cos of theta minus 53.1 degrees. And these are all degrees. You see, this one exactly is equivalent to 2. So don't waste your time. Just do the needful. So when you have this, divide by 5, divide by 5. So we shall have cos of theta minus 53.1 degrees, giving us 12 over 5. 12 over 5. Now have your calculators with you. So we shall have theta minus 53.1 degrees should be the same as the arc cos, or the cos inverse of 2 out of 5. Now looking at this, theta minus 53.1 degrees is giving us which answer you have?
66.42 degrees.
66?
66.42 degrees.
42 degrees. When you get this, the arc cos, you get 66.42 degrees. Now get the other angle if it is a cos. And 66 point, it is around here now. Meaning that cosine is positive in two quadrants. The first quadrant, cosine is positive. The second quadrant, sine is positive. The third quadrant, tan is positive. And the last quadrant, cosine is positive. So if this one is here, it is as well as the same as the other one will be somewhere here. So we need the positive part of it. Since they say from 0 to 360. So get 306 and subtract of this. What do you get?
You get 293.5. 293.58
degrees. I'm assuming I'm getting real values. I'm assuming what I'm getting are the real values. So, what about theta? Theta now will be, take this one and add it on each of those ones. So we shall have theta equals 66.42 plus 53.1. What do you get? $66.42 plus 53.1.
You get 119.5.
119.52 degrees. Then when you get this one added 93.58, what do you get?
You get 346.7
degrees. So therefore, the value of theta, wherever you're writing the final answer for the values of theta, is always, let me know if these figures are right.
Yes.
The values of theta will always use a color bracket. Say 119.52 degrees and 346.7 degrees. And you've solved the equation finally. Now, I'm going to do one more question. The question that I'm going to do is not solved, neither is it anything. We are going to do a question that has minimum and maximum value. How do we get the minimum? How do we get the maximum? But before that, wherever you're doing our formula, make sure that the nature of the equation determines the type of ratio you use. If they start with a cos, please go back to the cosine expression. When they start with a sine here, go back to the sine expression. From the first moment to the last moment, always know, wherever you're getting alpha, it is the arctan of b over a. And b is always, if at all we had sine theta plus 4 cos theta equals anything, b will always be the coefficient of the second trigonometric expression in any equation given to you. Hope have been noted very clearly. Yes, one last question about, no, I may not even have a question about minimum and maximum. Look what it is. Let me finalize it here. We've gotten this as our answer for expression. If they ask for the minimum value of this, your mind shall go, what is the minimum value for a cosine? The minimum value for cosine is always -1, and the maximum value for cosine is always 1. If this is the case, and the question asks for the minimum value of the expression, what you do, you look for possible ways of this one becoming -1, -1 because the minimum value of this expression happens when cos of theta minus 53.1 equals -1, and the minimum value here will be -5. When they ask for the maximum value of this expression is +5. Why? Because it must happen when the cos of theta minus 53.1 is always 1. Now, the task will be, for which values do the maximum value occur? The maximum value for this being 1, so we shall have the cos of theta minus 53.1 shall need to be, the whole of this, the cos of theta minus 53.1 shall need to be what? 1, to have this one as a maximum. So when you do this, look for the values of theta, cos of 1, then take 53 the other side. The value of theta is what they will be needing you to have. For which value of theta does this one become a minimum or a maximum? I think that is all for the arrow formula. Yeah, that's all for the arrow formula. If you put everything the way we said it, I'm just leaving one question for you. Check for me one question there, just a question. Just a question for whoever that may need to have a trial. Yes. A trial question.
Solve sin theta plus root 3.
Solve the equation. Sin
theta plus root of 3 cos theta is equal to 1
equals 1
for values of 0 is less or equal to
for values of theta from 0 degrees to
from 0 degrees less or equal to theta.
Yes.
Less or equal to 360.
So 360 inclusive. So when you're doing this, A is the value of A now here, the coefficient is 1. The coefficient of sin theta is 1. So your A is 1 and your B is root 3 in whatever you do. Get R, get your alpha, do the needful. Since they've started with a sine and a cos, look what this expression for sin theta plus, it is sin A or sin theta plus alpha has been maintained at a positive. Thank you so much.